Hello there, this is the Maths Tutor Online. This short tutorial is going to be focusing on differentiation and integral calculus at first principles. Now, before we go on with the tutorial, this is a very paramount topic. I thought that I should just let you know, because differentiation and integration is used from high school to university, and it's used in all subjects, the sciences, the arts, commerce, business, economics, programming. Okay, so it's gonna come in really handy in all your studies, and it's got real life applications, okay, that you can use in business or in health and medicine, as well as in astronomy and mathematics. Okay, so I hope that you enjoy the tutorial. Okay, from first principles, the derivative of a function y is called dy over dx and is equal to n times x to the power n minus 1, where n was the power of the function. Okay, so when you're given a graph of y against x, dy over dx is sometimes called f prime x, okay, which is the derivative of y with respect to x. Okay, so in physics, okay, it's very useful. I'll just use the example of physics. Okay, the velocity is obtained from this function right there. The velocity is the rate of change of displacement with time. So if you differentiate the function of s with respect to time, you obtain the velocity. If you have a velocity time function, if you differentiate the displacement with respect to time twice, okay, you get the instantaneous acceleration of the function. Okay, these are very useful when the motion is not uniform, okay, or when the velocity is not uniform and we want the instantaneous velocity and acceleration at those particular times. Okay, so here is a short example that you can work on. An object moves along a straight line so that the position at time t seconds is given by x is equal to 2t cubed minus 6t, where t is greater than or equal to 0. First part says find expressions for the velocity and acceleration of the object. Okay, so we already said the velocity is the first derivative of x with respect to t, and the acceleration is the second derivative. Okay, so if we differentiate that function, it will be 3 times 2, which is 6, t to the power n minus 1, which is 2, minus 6, okay, because t to the power 1 minus 1 is t to the power 0, which is 1. That's why we remain with 6, minus 6 there. Okay, the acceleration will be just 2 times 6, which is 12t. Okay, that term, if you differentiate a constant, it goes to 0. Okay, so that's the first part of the question. The second part of the question says find values of x, v, and t and a when t is 0, 1, 2, and 3. Okay, the solution that you're supposed to come up with for part 2 is that one. Okay, let me just put it right above there. That's part 2 of the solution. Okay, so you can pause the video, work it out, and make sure our answers are tallying. Okay, then part 3 says sketch graphs of x, v, and a against t. So you can pause the video, sketch the graph of x against t, means x on the y-axis and t on the x-axis. You should come up with something like that. Okay, so that's the graph of x against t. Okay, and next they say sketch the graph of v and a against t. Okay, when we work those out, okay, we should come up with that graph of v against t, graph of A against T. Okay, there it is. It's a straight line there. Okay, and V against T, it's a curve. Okay, a parabolic curve. Okay, so those on the left hand side are just the descriptions of the motion that is being described by the graphs. Okay, so you can take these home as your homework. Do numbers 1 to 4. Okay, and you can get back to me with your solutions, and then I'll mark them for you. Okay, I hope that you enjoy this homework. Okay, so next let's talk about the integral calculus. Okay, that's the reverse of differentiation, integration. Okay, so how can you find an expression for the position of an object when you know its velocity in terms of time? Okay, so you just integrate. Okay. One way of thinking about this is to remember that v is equal to ds over dt. So you need to do the opposite of differentiation, that is to integrate to find s. And if you have v is equal to ds over dt, if you multiply both sides by the denominator of this function, you get ds will be equal to v dt. And if you integrate both sides, you get s will be equal to integral of v dt. So here we're only talking about first principles, guys. First principles integration and first principles differentiation. Okay, so let's just look at a quick example. Say the velocity in meters per second of a model train moving along a straight rail is given by v is equal to 0.3 t squared minus 0.5. Find its displacement from its initial position after time t and after 3 seconds. So the solution is as below. The displacement at any time t is s is equal to integral of v dt. And because the integration is reverse of differentiation, okay, we bring our function down. There it is. To get the integral of this, it will be 0.3 divided by the power of t plus 1. Okay, so it will be 2 plus 1. 0.3 divided by 3. Okay, it will be 0.1. Then we remain with t to the power n plus 1, which is 2 plus 1, which is t cubed, minus 0.5t. Okay, plus a constant of integration. Why is it 0.5t? Okay, because we're integrating this term, this constant right there. Okay, so we have 0.5 divided by n plus 1. Initially the power of t is 0. Okay, so it will be divided by 1. Then it will be t to the power n plus 1. Okay, n initially was 0, so it will be t to the power 1, which is t plus c. So this is an arbitrary constant which it has to be there all the time when you integrate. Okay, to find the train's displacement from its initial position, we put s is equal to 0 and t is equal to 0. Okay, we know that when time is 0, the displacement s is 0. That we can use that to get the constant of integration c, okay, which will be 0. The final function will be s is equal to 0.1 t to the power 3 minus 0.5 t. So we can use that to find the second part of the question. To answer, we substitute t is equal to 3 in that equation. Okay, and after 3 seconds, t is equal to 3, so s will be 0.1 times 3 to the power 3 minus 1 minus 0.5 times 3, which gives you this expression right there. If you simplify that, you get 1.2 meters. Okay, here's another example. Okay, I'll just take out the solution. So you can work out that example. You can pause the video and work out that example. Okay, you can hit me up if you want the solution, or you can pause the video and check the solution later. That's the solution to the first part of the question. Okay, then that's the solution to the second part of the equation, of the question. So that's just our short tutorial on differential and integral calculus first principles. I hope that you enjoyed watching the tutorial. Okay, and we thank those who are giving us positive comments and positive feedback. We hope that you enjoy the tutorials and you continue studying hard so that you can get your good grades and get it over with school, okay, and move on to the next stage in life. Okay, so those are our contact details on the email, on the video. Okay, we've got the email, Skype, and WhatsApp, and you can call me anytime if you want to schedule a tutorial or if you want to make a donation. Okay, and as I said, we keep rolling out these videos free of charge to help the disadvantaged and the less privileged in our communities. Okay, we'll be really grateful for any donation that you can come through with. Okay, so we'll continue with the 1000 videos challenge inspired by Tupac Shakur and the ultra athlete David Goggins. Okay, so far we coming up close to 20 math videos. Okay, we'll produce another 20 physics videos, 20 accounting videos, produce 20 chemistry videos. Okay, probably 20 commerce videos, and in a short space of time we'll be at 100. Okay, and we'll take a short rest after producing 100 videos, and then we'll see where we can take it from there. God willing and sponsorship willing, we'll shoot right to the top, and hopefully most of you will be done with your studies, and these videos will continue rolling out for the next generation so that they can get free education, okay, hassle free distance learning, okay, at almost zero cost. Okay, so thanks for watching, and thanks for the support, guys.